Hi folks, this is Hector Camps from PHI Cubed here with Juan Camps, and we're going to show you a demo demonstration of automating a conveyor system. So here you're looking at a CATIA model, multidisciplinary model of architecture, structural, mechanical, electrical, plumbing systems. I don't think we have fire protection in this model, but essentially what we have here is a systems model. So we've mocked this up for the purpose of doing today's demonstration. Um, let's go ahead and look at, let's go to window and look at the drawing for a second. So we've also created a layout view, everything taken from the model, no drafting involved here. And as you can see, we have a view of the first floor, as it is showing the structure and some of the components that are in that first floor. And what Juan is going to do, he's going to do a preliminary layout of the space using space reservation. Then we're going to come back to this and we're going to update the drawing to verify that the drawing in fact is being created from the model. So Juan, if you may, let's go ahead and get started.
Okay, so what I'm going to do is I am going to run a preliminary route. It's called space reservation, and by doing that I'm also going to make sure that it's clashing against some systems. And as you can see, as I hover over the space reservation, you can see on the tree how it turns orange, so you always know what you are looking at, or easy to find it. So I'm in the process right now of moving the space reservation to make sure that it collides with the columns. Not yet. Let me just move it over a little bit more, and there you have the collision. So I'm going to go to the drawings and update the drawings.
So Juan has clicked on the update button, and this will take the new geometry from the model and it would update the layout. Fantastic. So at this point we have the model laid out, and we're going to go back to the 3D model.
Alright, so we are at the 3D model, and because this is a very small model, visually you can see the collision. But in more complex building, we have, the tool will help us to identify those collisions. So,
as Juan works on the model, Juan brings up a good point. At this stage, we're using the space reservation to create. We're using the space reservation to create a coordination model. So, for example, the planner, the person who is designing and laying out this system, is going to be able to use this model as a strategy for being able to coordinate with others, find collisions, and before they commit to a more complex model, they're able to use the space planning tool to create a reservation within the building for routing their specific system, in this case a conveyor.
Alright, so I'm going to go ahead and run the clutches.
We may need to look at that again. Go ahead and click on it one more time, Juan. I don't think we would probably have to reselect the model. The problem is there's no selection on number 2.
So as you can see, you can ask for what two systems you need to do. So now just hit apply, and there you go. So
Right.
it's showing the clutches in this little window, And if we go from on the right hand side window, you click on one and it takes you to the next clash.
So essentially we have, in reality, we have two clashes with the structure, and you can see as one clicks on the model, the different components highlight, and you have a little preview window which one could zoom in and show you that in fact there is a clash, and CATIA is helping you do this. I think this is a very important process because what you'll notice is that we're doing the clash detection in the context of designing, developing, and engineering the model. In other words, we're not going out to a third-party application out of the modeling environment or out of the model authoring environment to run our clash detection, which effectively allows us to run clash detection in 3D in real time across discipline in a coordination meeting. I think you would find this as a major advantage to other strategies that are currently in the marketplace right now.
Alright, so I'm going to go ahead and since this is a simple resolution, I am just going to move the systems away from the columns, hit apply, and the problem is resolved. I'm going to go now to the drawings, and the only thing I'm going to do, as you can see here, in the previous drawing you have the collisions. All I'm going to do is update the drawings, and they should update to the new corrected version.
Right now we're showing that this process updates manually. It could be configured to update automatically if you would like. All the updates right now we have them set to manual, so you can see the change is actually happening. But it is possible to fully automate the updates, so you don't even have to click on the button. Essentially, as you make changes, your documentations, your models, your everything, your schedules, your bill of materials, everything would update automatically.
So now you see that the change have been made, or the update is already made, and it's a collision-free system.
Juan, would it be difficult for you to expand the conveyor in between these two columns and pull it down?
Keep it running?
Yeah, keep it running between those two. So Juan's now going to show us how he takes the space reservation and updates it with additional runs.
Alright, so all I need to do is come to the space reservation tool, click on it, hit OK, and there you have it. I'm just going to make sure that it's not colliding with the column, so I don't have to go to the same explanation.
Before you get out of there, can you get rid of that node so we can make it one continuous system?
Exactly.
Pretty smart there, Juan. Pretty smart. And yeah, definitely let's get a clash. Let's get a clash in between those columns.
Alright. So I just extended the design, due to whatever change on design. And remember, this is on the design intent model or level.
Juan brings up a good point. This is our strategy, so when you're working on early phase design intent, this is actually how you would approach the modeling for most systems. This is not only true for this conveyor system and what we're doing. This is not only true for the conveyor system, but it's also true for any kind of system, whether it's fire protection, plumbing, HVAC. Our modeling strategy always involves a two-part process. One, where you create a space reservation, and then two, where you create a detailed design of that space reservation or on top of that space reservation. So what you will see here in the next couple of minutes is that the space reservation is intelligent and actually is a design driver that will drive the more detailed construction fabrication level model. So perfect, Juan. Let's go back to the drawing, update the drawing. and then we'll update a clash. Perfect. So at this point, we see the new drawing has been updated, and we see that we have a clash with one of those columns. So one, if you can, just go back to the go back to the model and rerun the interference check, and just exactly hit apply. And as you can see, one's going to zoom in there and show you that the clash in fact is happening. And CATIA will point out in red the cross section of the member where it's being hit. Fantastic. And it highlights it on the model.
Alright, so now what I'm going to do, once again, I am going to correct the, eliminate the clash by just moving it over a little bit, making sure that it's not colliding anymore. And once again, I'm going to go back to my drawings and update the drawings. Here you see the collision, and right now I'm going to go and hit the update.
Alright, fantastic. So the model is coming alive at this point. So the point is that all of our documentation process is data driven and model driven. So no drafting was involved, no manual hand drafting or even digital drafting on the computer was done. Everything is being driven from the model, and all the documentation is being generated for the model for field coordination installation purposes. Okay, so at this point we're happy with the design. We'll probably make a few more changes. I'm going to ask Juan, leave a clash on the model and maybe adjust off of this edge just a little bit here in the system, so it's not running so close to the edge. And then what Juan's going to do, he's going to use a knowledge-aware model to populate this space reservation or this design intent model with a manufacturer product specific assembly of a conveyor system. Now the one that we're showing here is actually going to be generic for the purpose of our example, but it could be absolutely done with anyone's intellectual property. This could be manufacturer specific.
Okay, so now I am in the process of actually putting the parts on the space reservation. So I just went to the library and look up the specific parts for this design. And all I'm doing is asking where those parts are going to be placed. I'm just going to change now the parts, and I'm going to do exactly the same.
So Juan is now populating the design intent model with a knowledge-aware model capturing all the company's business intelligence on how these systems work. They are fully automated. They have been programmed to behave exactly the way we want them to behave. And you see that as Juan goes through the model, the space reservation, they're being populated on top of the run.
So now we have a construction and fabrication model. In other words, we went seamlessly from a design intent model to a construction fabrication model. And I'm going to go to the drawings and update the drawings, and you can see how we are also generating the construction fabrication model documentation.
Correct. Well, if you can zoom into the drawing so we get a better look. Perfect. So at this point you're seeing the documentation that's coming from the model, and you can see a little bit of the hatch patterns and the actual rollers that are part of the system. Now we purposely and intentionally left a clash to kind of go back. Let's say there was other design changes with the structure. or there was field conditions that we didn't foresee in this sort of early phase coordination model that we were working with. What now? Does this mean we have a lot of rework to do, or is this intelligent system going to allow us to navigate this coordination problem that we have here? So Juan, go ahead, let's go back to the model. Let's run a clash detection now with the full assembly in place. And as you can see, the very first one is showing us the column crashing through not only the space reservation, but also the model. So if one just zooms in there, you can see that the column is, of course, going through the conveyor and all these things. So before you get off of this, just note, folks, that every single object is being collided with is in the clash detection. We're not going to go through all of them, but we're going to state that this clash is relevant, and we're going to then now labor towards getting this result. Okay, Juan? So let's go ahead and close out of this, and let's adjust the design through the design intent model, the space reservation, and have the construction fabrication model update.
Exactly. Just keep in mind that this space reservation is has the intelligence to change any construction and fabrication models. So here we go. I am just going to select the path reservation and move it a couple of feet away. I'm just going to turn around the system to make sure that it's free of collision. When I hit apply, I can see the space reservation. If I am not happy with it, I can just move it back and forth. So that gives me the ability to see where I want my new system. So if I'm happy with the location, click OK, and then just update, and you're going to see how the actual part is going to update to the new location.
Now, when Juan says part, he's not just saying one part. He's really talking about the entire assembly updated to follow the space reservation. So this would have been significant amount of rework for somebody to regenerate the CAD, the drawings, the floor plans, the bill of materials. So all of these things are now fully automated. If he goes back to the drawing, of course, as you know, the documentation will now be updated to represent the new condition. Now you can imagine that this level of coordination can happen live, can happen in real time, and can even happen in a coordination meeting with the clients and with other disciplines. Okay, so at this point we've generated the drawings, the field implementation documents from the model. They are now coordinated and ready for field installation and for fabrication. Well, let's just take a look at the model for a moment. Point out a few things that we thought would be cool. Can you go to annotations for a moment and go to views? So we have this model organized by level, and for example, one, if you can just go to level 1, right click on that and say display view, zoom out and put it in isometric view. We're able to look at the model, right? We're able to section off the model in different levels. So as we're working through a model like this, zoom in a little bit better so we get a better view of the model. Great. So as we can go through the model, work in different areas, we can focus on different parts of the building as we're working on it. We don't have to view all the information. Both section views and 3D views are all being taken from the model. This is important to mention because all of our section and all of our detailing are true takeoffs from the model, and we can position these things anywhere in the model under any standard that we want to work with, and I thought that this would be worth mentioning. Okay, folks, thank you very much for attending this animation. I hope you enjoyed it. In the end, if I had to leave you with one message, the big idea behind what we're doing here, there's a few takeaways I'd like to mention, but one of those takeaways is that I always tell our clients, you know, everybody wants things fast, but it's hard to do things accurately when you're working fast, and slow and accurate is also undesirable as well. People usually want fast and accurate. So by implementing KnowledgeWare on CATIA and the 3D Experience platform, you're able to manage and automate a very large amount of building complexity. So just keep that in mind. Next time you're at your next coordination meeting, we've been sort of joking lately that with the CATIA and the 3D Experience platform, there is no coordination meeting, right? All of our coordination can be done in real time, effectively eliminating the amount of time that you need to go to coordination meeting. Not to mention that you can fully automate the entire document production process from the model. So with that, folks, knowledge capture in reuse is a fabulous way of capturing your company's intellectual property and automating it and putting it into a building assembly model of your next project, which will allow you to largely automate the design and engineering process. So again, I'd like to thank you for taking time to meet with us. This was Hector Camps of PHI Cubed and Juan Camps signing out. Thank you very much and have a fantastic day. Bye-bye.